Solve the initial value problem y double prime minus 3y prime plus 2y equals sine of t, where y of 0 equals 0 and y prime of 0 equals 1/5. As usual, we need the complementary solution first, and as usual, I'll let you find that yourself, so press pause, find the complementary solution, and then press play when you're ready. You should have gotten that the complementary solution is c1 e to the 2t plus c2 e to the t. Remember, it's too early to apply the initial conditions. We can't do that until we have the full general solution. Next, we need our guess function. For this problem, the non-homogeneous term is sine of t, so our guess is yp equals a sine of t plus b cosine of t. So yp prime equals a cosine of t minus b sine of t, and yp double prime equals negative a sine t minus b cosine of t. Plugging these in, we get negative a sine t minus b cosine t minus 3 times a cosine t minus b sine t plus 2 times a sine of t plus b cosine t equals sine of t. Or negative a sine t minus b cosine t minus 3a cosine t minus 3b sine t plus 2a sine t plus 2b cosine t equals sine t. In order to find the values of the coefficients, we need to group all of the sine terms together and all of the cosine terms together. Simplifying, a plus 3b sine t plus b minus 3a cosine t equals 1 sine t plus 0 cosine t. Now we can use a technique called coefficient matching to write a system of equations involving a and b. Once all like terms have been combined, the coefficients of terms on the left must match those on the right. Specifically for this problem, we need the coefficient on sine on the left to match the 1 on the right, and the coefficient on cosine on the left to match the 0 on the right, since there are no cosines on the right side of the original equation. So we get a system of two equations, two unknowns. A plus 3b has to equal 1, and b minus 3a has to equal 0. How you choose to solve this system is up to you. I'm going to use substitution and say that b equals 3a, so a plus 3 times 3a equals 1, 10a equals 1, so a equals 1/10, and therefore b equals 3a equals 3/10. So yp is 1/10 sine of t plus 3/10 cosine of t. Our general solution is then y equals 1/10 sine t plus 3/10 cosine t plus our complementary solution c1 e to the 2t plus c2 e to the t. And we can finish the problem by applying the initial conditions, y of 0 equals 0 and y prime of 0 equals 1/5. Since y of 0 equals 0, 0 equals 1/10 sine of 0 plus 3/10 cosine of 0 plus c1 e to the 0 plus c2 e to the 0. Sine of 0 is 0, and cosine of 0 is 1, so 0 equals 0 plus 3/10 plus C1 plus C2. And C1 plus C2 equals negative 3/10. Y prime equals 1/10 cosine of t minus 3/10 sine of t plus 2c1 e to the 2t plus c2 e to the t. So since y prime of 0 equals 1/5, 1/5 equals 1/10 cosine of 0 minus 3/10 sine of 0 plus 2c1 e to the 0 plus c2 e to the 0. So 1/5 equals 1/10 plus 2c1 plus c2, and 2c1 plus c2 equals 1/10. So to finish the problem, we need to solve the system c1 plus c2 equals negative 3/10, and 2c1 plus c2 equals 1/10. I'll solve this system by elimination and start by subtracting the first equation from the second equation. When I do that, I get C1 equals 4/10 or 2/5. Now I can use the first equation to solve for C2. 2/5 plus C2 equals negative 3/10. So C2 equals negative 3/10 minus 4/10, which equals negative 7/10. So our final answer is y equals 1/10 sine of t plus 3/10 cosine of t plus 2/5 e to the 2t minus 7/10 e to the t.